All right, so here is the last section in this unit, chapter 6, everyone's favorite word problems. So you'll notice once I go through these three examples here, there's going to be a little bit of a pattern as to the types of questions you will see. And with that, hopefully everything will be able to make sense and you can work from there. Just like in last unit, there's kind of a pattern as you went along. So let's dive into this first example. So we got a candy company, they're selling boxes. The box has a square base, it tells you the sides of those, it tells you the volume, and then it says it wants to redesign it so that you have a smaller base of the box. It's squared, but you want the same volume. And we want to see what happens with that. So you can imagine here, if we draw out the box, if you want to draw 3D boxes here. So here we go. So the base of the box, these are all the same length. You're told that originally they're 17.5 centimeters. And you have that your volume is going to be 1,070 centimeters cubed. So the first thing we want to do is, what is the height of the box originally? Hopefully you know the area or the volume of a box. The volume is just the length times width times height. So volume equals, now because we have a square base, I'm going to just put the sides of the base, so side times the height. So this is the height of the box. And down here, these are the sides. So volume, 10,070 equals 17.5 squared times the height. And we get the height is 3.494. This is a rounded number. So this is our original height. Then we're asked to make a formula that's going to talk about the increase in height when if I decrease the side length. So taking this same equation, I'm going to rearrange it for the height. So for question B, height is equal to volume divided by the side squared. And if we decrease the side length here, we are going to increase the height. So what we can talk about is, here's the height. We're going to have some change in h, so delta just means change in. The volume stays the same, and we're going to have side length minus change in side length squared. Again, the side length gets smaller, so that's why I subtracted this. And what I want to do is I want to rearrange for the change in height. So change in height is equal to volume over s minus change in s squared minus the original height. The original height we have over here, it's 3.49. So I suppose instead of height, we could put 3.494 into the equation already. So this is my equation for change in height. Given, oh, and I have the original s too, don't I? So instead of putting s here, I can put this as 17.5. So volume divided by 17.5 minus change in s, because those values are known. So now in the next question, it says, if what is the increase in height if I have each of these decreases? So if my change in s is, so these are both my change in s's, my change in the side length is these two amounts, what are going to be my change in height? So all I'm going to do is take this equation, plug in delta s as 1.5, plug it in as 3, and get an answer. So for the sake of time here, I'm just going to do this quickly. So for C, change in height is 1070 over 17.5 delta S, and I'm changing it by 1.5 centimeters. That's all squared, minus 3.494. This will give me 0.686 centimeters. Oops, sorry. So that's what you'd get as your final answer. This is centimeters. D, exact same, just plug in 3. I'm not gonna do D. That's an insult to your intelligence. You just change 3 in for 1.5. Not too bad. For E, you are told what the new height is. So it says, what is the length/width of the base that yields a height of 3? So in this one, we have the height. So we have h plus change in h. So we have this is simply 3. So 3 equals v over you know what? I'm going to make this simple for you. So let's just calculate what my side is first. That's all I need for this. So what is my side length? And I have the volume. Why did I put V? We've got 1070 in here because that's my volume. So solve for S. So S squared equals 10,070 over 3. So my side length, if I plug this into my calculator here, because I'm doing something different so I don't have it in front of me, divided by 3, and then take the square root of that. So we get the side length is 18.88, and that is the length. So we didn't want what is the change, we wanted just what is that length. And this would be centimeters. So there you go. There's that question. Moving on to the next one. All right, again, sorry about that. I have to splice these videos together. Okay, so like I said, this is something that some of you did in your project last unit. So let's give this a go. We want to do some calculating for this. Now, first we need to set up an equation. So for this equation, it's talking a lot about time. So I don't know if you remember from science, time is going to be equal to distance over speed. You might see it as S, I put V, doesn't really matter. If I want the time, I need the time that it takes to go from Lethbridge to Moose Jaw, plus the time it takes to go back. So both of these cases, so let's look at the time it takes to go there. So it's gonna be distance, which is 500 kilometers, divided by the speed. So when I'm going there, I have a tailwind. The tailwind means the wind is blowing with me. So I'm going the airspeed plus the speed of the wind. So this is going there, plus the time it takes to go back, so distance over my speed. Now the wind is against me, so I'm going to subtract that. So here's my equation for time with that. For A, it's 30 kilometers. Again, for the sake of time in this video, for A and B, I'm just going to show you A here. So for A, I'm going to put in, I want to know what the time is. So you're just going to put 500 divided by 165 plus 30 plus 500 over 165 minus 30. And this is going to give us 6.27 hours. So that one's the easy one. When you're plugging in on this side, it's pretty straightforward. It's this other one that's not going to be too easy, and that's going to be C, and I wanted to spend more time on that because that's the trickier one. So if I look at C, I'm told what the time is, and I need to solve for VW. So if I write this in the equation, it's going to have lots of space here. So I'm going to have 6.25 equals 500 over Again, I'm going to make this simpler for you. I think I'm going to do it a different way here so that, oh no, I can't do that. Never mind. There is no easy way for this. You just got to do it the hard way. I'm just going to call it V so I don't have to keep writing the same variables. 500 over 165 minus V. So I need to solve for V. And how I'm going to solve for V is using what we used in this unit. I have a denominator. I have two denominators. I need to times by something that will get rid of both denominators. So what I'm going to do is I'm going to take both sides of this equation and I'm going to times it by 165 plus V times, sorry, I don't have space, times 165 minus V. So I'm going to multiply both sides of this equation by this to cancel out the denominators. So what I'm going to be left with in this case is on the left-hand side, 6.25 times 165 plus V, 165 minus V. So again, we multiplied both sides by both of these brackets. I just put those there, equals, so when I multiply both these terms into this fraction, the 165 plus V's will cancel. And I'm left with 500 times 165 minus V. For this other fraction, the 165 minus V's are going to cancel, and so I'm left with 500, 165 plus V. So this is my big, long, ugly expression. The algebra for this is not too bad. You're just going to expand the brackets. So I'll show what that looks like. If I multiply all of this together, what I'll get is numbers. Lots of numbers. If you want to know where this comes from, sorry, this should be V squared equals, and then on this side, it's actually going to cancel to something simple like this, and then just solve for V. So you'll end up with V squared equals 825. So V is equal to plus or minus 28.72, but it doesn't make sense to have a negative speed, so we're just going to use V equals 28.72 as the positive value for this. So that would be that example. Oh, I guess I should put units for a physical example like this, especially if you can only take physics with me. You will need to know these units. So there we go. That is your speed for this. Again, I skipped a few steps in here. If you want to see the process, I have another sheet of paper here. Actually, I can quickly show you what that is. So here's the expression. You multiply these two together to get this. Multiply these in, you'd get this weird expression, and stuff cancels. So if you want to look at that in slow motion, you can pause, take a look at that, and see if there's parts that you want to understand with it. Otherwise, don't worry about it. Okay, last question here. So we've got a square poster. You're told the area, and what you're going to do is you're going to change the length by a little bit. So what I've got in this situation, it's great to show a picture for it. You've got a square. You're told your area is 1.5 meters squared. Originally, the sides are all the same, but we are going to change something up. So originally, my original side is going to be, well, I just take the square root of this. So the original side is just 1.5 squared. That's the original side length. And now we're going to solve some questions with this. So determine a formula to calculate the width. So my width, remember area is just length times width. So width is area over length. Not too bad. Now, if we are going to, what does it say? What is the new width for each increase in length? So these are increasing in lengths. So let's take a look at this. So I'm just going to do one of those. A, we're told what is the new width if I increase by 10. So what is my width when my area stays the same, 1.5, over my width for this. So my original size is square root of 1.5 plus, I'm going to add the new width. The problem is my units are different. Notice my units here are centimeters. I need to change this to meters. So divide by 100, I'd get 0.1 meters. So just be very careful with the unit for that. So plus 0.1, plug that in your calculator, you get some number. I'm going low, time is running out, so I'm just going to show you that. So you'd get some number. Plug that in your calculator, you get a number. For C, we want what is the change in length. That'll give us a new width. So we are told we want to know what is the width, and you've got the area divided by my new width of 85 centimeters. So I've got, let's see. Sorry, this is 0.85. 0.85. And we've got the length down here. So all we're going to do, first solve for the length. So length is equal to 1.5 over 0.85. I've been doing that whole thing out of frame, I'm sorry. So 1.5 divided by 0.85. This gives us 1.765. This is meters. Now, it asks for what is the change in length. This is what the length is. I want the change in length. So what I'm going to do is I'm going to take this. My change in length is going to be equal to 1.765 minus the original length, which is 1.5. So that minus the square root of 1.5 gives me 0.54. Again, meters. So this is going to be my change in length. This is letter C. So there you go. That's the process for the word problems. I'm sorry this one went a little bit longer. If you wanted to skip any of these examples, you're more than welcome to. However, I know with word problems, it's better to see more examples. Again, if there's a process in this that I went too quickly over that you don't understand, please come and ask me in class because I can explain that in detail. So there we go. That is the last section, and that concludes rational expressions.